first of all, I'd like to say thank you very much for inviting me, and Travis for inviting me to speak to the group. It's quite exciting. So I know I've only got about 15 minutes. I've got a number of slides, but I'll go through it reasonably quickly. And if you have any questions, then either feel free to stop me, with a hand up, or just stop me, or we can have a, if you have any questions afterwards, that's perfectly fine as well. So really, it's about locating and mapping your utilities simultaneously. And so Terraflow Geomatics, a Canadian company just based out of Toronto. And we build products to help utility locators and people in the subsurface utility engineering space be able to collect their data at the same time they're doing their locates. So really, it's a focused, easy to use system to locate and map the utilities at the same time. So it really focuses around questions about, are you concerned about the accuracy of hand sketched maps? Are you frustrated by the amount of time it takes to complete a hand sketch, or capture that GPS data after the fact and make sure that you've got everything mapped properly? So effectively mapping the utilities. So we generally, with people, we run through the basic requirements around what their workflows are. It's a highly configurable system to enable you to design the workflow precisely as you want it. Designed. Focus on capturing accuracy. We can leverage a number of different GPS products. So Trimble, Juniper, EOS, in order to get those accuracy levels down to centimeter level accuracy, for example, sub-meter, depending on whatever those requirements happen to be. Again, it's focused on data collection, and that's sort of basic set of questions. And so you've got the standard locate process where you put the paint on the ground, but at the same time then to be able to capture that data, synchronize it with the back-end GIS system so that you can then produce images, three-dimensional maps if you wanted to do something along those lines. So the classic process, we won't spend too much time, you guys are probably, or won't spend too much time on this, but basically you've got the ticket request, you perform the locate, you measure your offsets, and then you would sketch the map out by hand. It's the typical way that it's often done. Submit the sketch and then close the ticket. The biggest issue here is, I think you've identified, is the fact that that data never makes it back into a GIS environment that you could then leverage going forward. From a more automated perspective, and what we're bringing to the table is, again, you have ticket requests, or you have some reason to be out there. For example, it's a subsurface utility engineering project. You go out, you perform your locate, and at the same time, you capture that information with GPS. You can also capture all of the GPS offsets. So if you wanted to be able to do offset markings from hydrants or from curb lines, you can capture all of that simultaneously. You then synchronize the data. The sketch is then auto-generated for you, so you can print it off in the truck to hand over to the client, or it can also be pushed directly into a back-end GIS environment, whether it happens to be ArcGIS Online or an ArcGIS portal environment, or some other type of system like QGIS or one of the open source GISs that are available. So from a mounting perspective, just a couple different examples of people utilizing the system. So the software itself is running, in this case, it's running on a Trimble ruggedized handheld, but it will support any Android-based phone. It's connected, in this case, to a radio detection RD8100. We do support the RD8200, as well as the Vivex MetroTech, the VLOC2, the VLOC3. And we're looking at adding subsite support as well. So basically, any of the locators that can produce a Bluetooth string, we can capture that data and marry that data with the underlying GPS information. Some people use the system pole mounted on a backpack. Some people mount it directly to the locator. It really depends, again, on the workflow that you're doing, the kind of work that you're doing with the system. The best combination or the best mounting system that you might want to have for it. So the workflows themselves, and this is one of the key things that we look at doing, is configuring the workflows to match exactly what the people want to, or what the locators want to be able to see. So everything on these screens is entirely configurable. So there's a set of workflows depending on what you're capturing, what the project might happen to be. You can define a set of workflows for that person who's in the field to go through, whether they're daylighting something, whether they're capturing water assets, sanitary sewer, all of the colors, would match a one-call colors, for example, to really clarify things on the map. Inside of the workflow, we have the ability to capture what we call manual data or locate data. So anything that's within the context of the manual tab, and again, that list is fully definable, anything in the context of that manual tab can just be collected. It doesn't actually require a locator to be attached to the system. So if you're doing curb lines, for example, or if you can see the pipe and you just want to take a GPS point of the pipe and not utilize the locator, you can do that. Anything under the locate tab is actually driven from the locator itself. So as you're doing your work, every single time as you're conducting your locate, when you press save on the locator, it will then generate that GPS information and capture all of the data that's on the locator. So the depth of cover, the power ratings, the hertz, the frequency the locator is set to, all of that information is captured and associated with that GPS position that you've taken. There's also the ability to take photographs and synchronize the photographs back. So if you wanted to have a photo record, if the locator saw something out there and they were a little concerned or something was a little bit off, for example, about that area, maybe they wanted to take a picture of it, they can take that photograph and add to that record that they've created at the time of doing that locate. So in this, the final screen on the right-hand side, so we can see they've captured natural gas, gas meter. The error on this particular screenshot isn't great. We've got the latitude, longitude, the elevation information there. But there's also the ability to what we call connect to a point. So for example, it's a useful type process. Maybe you've got a busy roadway, for example, so you can locate up to one side and then, or a small river that they've done a directional drilling job underneath, and it's come out and they pick the locate up on the other side. What they can do over that area that's non-locatable, or at least non-locatable with an electromagnetic system, is they can connect from one side of the point and generate data to the other side. So they can connect those 2 points, and then the system will prompt them as to how they want those particular points connected. So in the case of a water crossing, again, the individual could walk up, they could do their locate to the edge of the water on one side, they could go to the other side, they could continue their locate, and then they could connect those 2 as well, and it will generate a perfectly straight line between them. From the perspective of in the back office, then there's a record that information was generated instead of actually located, so that you've got that backup to say, what exactly happened in the field in that case. So in this case, if I connect the point, I can then select anything within the workflow. So I could say it's a gas service or a gas line that connected those 2 points together. So it's a bit of a mock-up data, but that's the idea behind that type of environment, that type of workflow. Again, it's really focused on how do you make that individual's job easier, more efficient, and how do we ensure that you're collecting high quality data and that you're getting all of the metadata back so that when you're looking at it after the fact, you understand exactly what happened in the field. Mistakes unfortunately do happen, so we also have the ability to delete information in the field so that they can update their information as they go, so that maybe there's a mislocate or something happened, they can just get rid of that data before they submit the final sets of data through the system. So a little bit in action. So again, in this case, it's the radio detection unit connected to a Trimble Catalyst receiver. So again, from a purely economic perspective, the Catalyst is a useful receiver. I don't know if anybody utilizes it heavily there. It's quite popular in Canada because of that subscription-based model. And so we do have a number of groups utilizing the Trimble Catalyst as well. Plus it's light and sits on the locator quite nicely. And then they're just doing a locate, in this case, an electrical locate up to this box. This particular individual is one of the contractors or one of the clients in Canada who was doing locate on, it was an Enbridge depth of cover survey. Jeff Zeiss actually wrote a blog post on it last summer. We'll talk about a little bit on a case study. This individual works for a company called PVS Contractors, which is one of the larger locate contractors in Southern Ontario. And he's doing a depth of cover survey in this case, utilizing a high accuracy GPS, utility mapper on the phone, and then he's collecting all of the locator information at the time that he's doing the locate here. So it's complete data capture. So we collect linear features, but we also collect all of the per vertex information. So as you're doing that locate, every single dot that gets placed, you've got the full metadata on each vertex, both of the GPS and the locator. And then we also will do a connect the dots, so it will generate all of that line work for you. So if you needed to generate a CAD file, or again, push that back into a GIS environment, all of that will come through very cleanly. So methods, there's what we call timed collection. So the system can either generate data explicitly as you're walking. It can also generate time data. So as you're going, it can stream information. There's manual collection, and then there's locator-driven collection as well, where they just set it to the asset type that they're collecting, and then they can go through and do their locate. And then they can jump off and do other utilities at the same time and come back to the original utility. So saves them walking up and down the length of the job site repeatedly. Ensures the best quality data and full traceability, which is key, so you know exactly what's happened. And then there's the full integration with ArcGIS, with AutoCAD, and more systems as well. So the case study in this case, the client, so again, there's a published case study that Jeff Zeiss wrote up about this, but the client was contracted to perform a depth of cover survey. It was a large pipeline that ran from Windsor in Southern Ontario through to Montreal in Quebec. So about 1,000 kilometers. It was a 9-month project duration was the estimate with 8 field staff. And then they had weekly data submissions, which they had to submit back to their client. They had done this work before using standard locate techniques with hand sketching and recording information on paper. So they were generating a lot of paper reports, and then they were trying to download information from the locators to get all of the information about the depth of cover from the locate sets. A lot of QA/QC and a high risk of data loss through that process is what they experienced. And there was a lot of data processing to amalgamate all of the data from the locators, to check for duplicate data, to check for missing data. Maybe there were gaps and they had to send people back to clean up those gaps. Or they had 2 different people locate the same portion of pipeline, just miscoordination on the job sites. And then there's a high risk of missing sections of the pipeline, and what they found out afterwards is after they finished the job, they would have to go back and clean up certain sections that they had missed. So for the solution, what they utilized was the utility mapper software. That's a system, as we've discussed, it's integrated with the locate sets. So in their case, they were using the Vibex Metrotech equipment to do the work, to automatically capture that depth of cover. That was their primary focus, and marry that with a high accuracy GPS, and they were using Trimble Catalyst for that. The system was synchronizing the data automatically, so every 10 minutes, the data would be submitted to their back-end ArcGIS online system. So their people in the office could get a near real-time perspective on exactly where everybody was. And the other key is that their field teams could see on their handhelds where other groups were as they were working and what data was captured. So a very limited risk of data loss. The data is always stored offline on the handset, but because we synchronize repeatedly and periodically, the fastest interval is about once per minute. Most people sync about once per 5 or once every 10 minutes. So really the maximum, if the phone dies for whatever reason, you're going to lose 10 minutes worth of data. So very, very limited risk of data loss in that case. And if they go into an area without cell, then as soon as they're connected, it will push all of that data back to the backend environment. They had real-time progress reporting with the system. And then all of that locate information, importantly, was synchronized with other crew members so that as other locators came through or as they were working together, they could identify the sections that were already completed And so they didn't relocate, and they could also see sections that had to be completed because you could bring the base map data in, the underlying asset infrastructure, into the environment. So they could tell where they needed to go and what hadn't been done as part of that particular contract. What they found, it took about a half hour of QA/QC. So Friday afternoon, somebody in the office would just go through in their ArcGIS Online environment, do a quick QA/QC. They'd export the data and submit it to their client. So eight crew members were deployed in the first 2 months. It ended up being productive enough. They reduced that to 5 people in months 3 and 4. And then they reduced that again to two crew members to finish off the rest of the work in months 5 and 6. So it was a significant cost savings and speed increase. And they already had the data in the GIS environment directly from the field, and so that they could work with that instantly. So the basic workflow is the utility mapper, the handheld component, writes the data to a backend data integration platform that we have called Data Engine. And the Data Engine supports direct read-write access to Esri. So as you're talking about the GIS work, we have a mapping environment that's built into Data Engine, but most of our clients actually utilize the Esri backend. It's very popular in Canada as well. And so we then just take that data and we write it directly into their ArcGIS Online or ArcGIS Enterprise, their portal environments. But we can also export shape files, geodatabases, AutoCAD files, depending on what the requirements are. As I say, the most popular that we have right now is that data just gets written automatically to the backend system. And then they can use their dashboard tools, they can use Geo Event Server, they can utilize all of the existing Esri capabilities to then take that further to make their maps, to do any subsurface utility engineering work. We can also read and write data directly to SQL, Oracle, a number of different formats directly from the system. So we do have a few other products as well. I know it's not really focused, but we do also have a pole mapper and a sensor mapper workflow that are based on the same backend. So we support sonar workflows, radiation, as well as pole engineering workflows. Data Engine, which just mentioned, is the tool that we utilize to transfer data from the handheld directly into your environments. It's a real-time data processing platform, also has data storage and custom data workflows that we host for other groups as well in a secure and managed environment. So thank you very much. Any questions? I hope I didn't go over my allotted time.
In your case study, Kieren, how did the GPS mapped pipeline compare to what they had originally?
Pretty good as far as the matching of the underlying pipeline. I didn't actually have access to the underlying data set, so okay. It was a secure environment on their side. So I know they were very, very happy with the solution. But as far as how close the GPS was to the underlying transmission line that they were mapping, I don't know exactly how well those two matched.
Okay, thank you.
Hey, Kieren, can you tell me, can you do ticket management into, I mean, how do you get a kind of a work order to get started to go do a locate if somebody was to use this with doing a one-call ticket?
So at the moment, we don't have a ticket management facility within the environment, so that would still be handled by an external ticketing type environment. So it's something we're looking at, but we don't have that as of yet.
Okay, and then you were talking about connecting the dots to create a line, so it doesn't automatically do points and lines at the same time, or how?
It does, yeah. So what happens is, if you select something, for example, the gas main, that is a linear type, then as you're collecting the dots, it will generate the lines simultaneously. So all of that happens at the same time as that person is working. Okay, and then how does that all sync up to, how does your data engine sync up to ArcGIS? It just uses the ArcGIS standard ArcGIS feature services. So as the data comes in, we do a data mapping between the workflow here and then the types of data that you want to capture in the feature service, and then we set up that integration, and then we just utilize the either ArcGIS Enterprise or the ArcGIS Online REST feature services, and then we can read or write directly to those.
And when you were saying it syncs every 5 minutes or whatever your parameters you said are, does that require an all-time connection with a SIM card?
No. So, I mean, it does require a connection to the internet for the synchronization to happen, but the environment or the handheld does store the data locally on the handheld unit. So if you don't have a SIM card, for example, it will collect the data, and the next time it is connected, then it will submit the data through, if you hotspot your phone, or if you go to a Wi-Fi hotspot, or you get home at the end of the day or back at the office, it will then synchronize the data that hasn't been able to synchronize up to that point.
And is this a monthly service or one-time cost?
It's a monthly service. Yeah. Sorry, who's asking the?
I'm sorry, Kieren.
Oh, Travis.
Okay. I'm the one sending you all these softballs.
No. That's fine. It's a monthly service. Yeah. I was just scrolling through the list to see who was. Yeah. Well, it's monthly or annual is how we work it. Yeah.
And then I saw one person was asking, it showed that you can connect to the radio detection, and I did see the Vivax on there too. And then you said subsite is coming in the future, right?
Mm-hmm. Yeah, subsite's not, we don't have any clients that are utilizing the subsite equipment. So it's radio detection and Vivax Metrotech in Canada seem to dominate the market. So those are the two that we focused on at this point. But we have had discussions with subsites, so yeah.
I know that Cancel dealer, or Tremble dealer Cancel in Canada, they've been selling this for how long? Have their customers been pretty happy with it, or
yep.
What's the action?
Yeah, no, it's so Cancel, which is the largest Tremble dealer, in Canada, resells the software, and so far they've been very happy. We're adding features and functions quite quickly based on user requirements, user need. But they've been selling it for just in excess of just over a year, and so far it's been a successful initiative for all of us, which is great.
You're muted.
Yeah, sorry about that. There's one last question that just popped up on the board. It says lat long or 12 decimal, but the depth is not. What is the accuracy we have generated, I believe, is what the question would be.
So the accuracy is whatever's coming off of the equipment. So we store the entire depth that's coming off of the underground locator. So it's really, from that perspective, it's very much equipment driven, depending on the locator you have and the quality of the signal that you've got at the time.
Okay. Well, are there any more questions? So hearing none, Kieren, thank you so much for taking time out of your day to come by and talk to us. Greatly appreciated.
Great. Well, thank you very much for having me. And I look forward to hopefully speaking with some of you again in the future.